Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called First Rodeo by James Sinclair. And here are the rules. Divide the grid into 9 orthogonally connected 9-cell regions, and place the digits 1 through 9 once in each row, column, and region, which is a 9-cell orthogonally connected region. Now, orthogonally connected just means that cells share an edge. So if cells share an edge, they are orthogonally connected. Therefore, a region that has to be orthogonally connected must contain 9 cells that are all orthogonally connected to each other. So this is not a valid region because the last cell in this region is not orthogonally connected to any other cell in that region. However, this would be a valid region because then this last cell, all the cells are orthogonally connected to at least one of the other cells. Actually, all the other cells in the region, right? Because you can find a way orthogonally, which means through an edge, to any cell in that region. And that's how, and this is called chaos construction rules, normally. Normal chaos construction rules. So that's how normal chaos construction rules work. A digit inside a circle indicates the sum of all digits in the same region that see that cell by a knight's move. Okay. The digit indicates the sum of all digits in the same region that sees that cells by knight's move. Now, knight's move is obviously two in one direction away and one in a perpendicular direction away. So these would all be knight's moves away from it, right? Now, of these 8 cells, or up to 8 cells that are possible around the circle, the ones in the same, you add up the ones that are in the same region, and that this number, this digit, is the sum of those numbers, of those digits. So say these two were in the same region as the circle, then you would add up what these 2 cells are, and it would have to sum up to this one. So say this was a 3 and a 5, this would now be an 8. If you had 3 of the cells that were in the same region, so say you had these 3 cells be in the same region, then this would be the sum of all of those 3 cells. So a valid example would possibly be 1, 2, and 4. This would have to be a 7 then, because these are in the same region as it, and these are a knight's move away. So that's what circles indicate. A digit in a square indicates a total number of cells in the same region that see that cell by knight's move. Okay. So the square is the total number of cells that see that cell by knight's move. So for this cell, say, well, this is impossible, but okay. Say all of these cells were in the same region as it. Then this would have to be 8, because 8 cells are in the same region, see it. And by seeing it, they are a knight's move apart, essentially, and are in the same region. So that's the rule for the squares. Purple lines contain a non-repeating set of consecutive digits in any order, and therefore these are Renban lines. So for example, if this were a 1, this would have to be a 2, because along the line you would have to form a consecutive set of non-repeating digits. So for another example, if this were a 1, you would know there would have to be a 2 and a 3 along the same lines. Or 3 or 2. Because 1 is only consecutive with 2, which is only consecutive with 1 or 3. And that would only be the only set that would contain a consecutive set, right? Because you can't have 1, 2, 4 because that's not consecutive, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So for this has to be 1 or 2. Because there's only 2 cells that can be a knight's move away from it. So it's at most 1 or 2. Similarly, this is 1 or 2. Because there's only 2 cells that can be a knight's move away from it. Therefore, we have a 1-2, 1-2 pair in column 1, so the rest of the column cannot be 1 or 2. This only sees 4 cells at most with a knight's move away, so it could be 3 or 4. But the interesting thing is, what sort of shape can you make that would fit all these cells in and include the square in the region? Well, what if we tried this? Say we tried 4. How would this connect? Well, you need to connect these two, obviously. So one of these is connected. So let's say this one, because that's the least restrictive. If you tried to do here, this is very restrictive then. So say we also tried here, right? So this is 1, 2, 3, 4, 5, 6. So that's possible. Then you could have 7 and 8. That's possible too, actually. So it still could be 3 or 4. That's very interesting. This is 3 or 4 then. Okay, so for for the circle, the sum has to be at most 9. So that means there's only 3 that are in the same region as a circle at all times, right? Because if you have 4, the minimum there would have to be 1, 2, 3, and 4 since they are in the same region. And that would be 10, which is not a digit. So the circles can only be next to 3 other knight's moves away that are adjacent, right? It could be 2, and it can never be 1, right? Because it's in the same region. If it's a sum of 1, it would be exactly the same number. But it's in the same region, so therefore you can't have duplicates. So therefore they can't be the same. So therefore, there's always 2 to 3 digits in all the circles that they are in the same region as. It's always 2 or 3. Let's not put it there. Just keep this as a reminder. So this is 2 or 3. This could be 1, 2, 3, or 4. Again, squares can never have 8 knight's moves cells away that are in the same region. What could it have though? It can have 4. We know we've shown that you can have 4. Right? It could be 1, 2, 3, 4, 5, 6, 7, then 8. I don't think you can have 5 though, right? Can you ever have 5 is the question. So say you had, I don't know. Say you had all of these connected, right? You need to connect this somehow, and that's the easiest way. You need to connect these somehow. Is this possible? How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is not possible. So for the rectangles, they have to be 1 through 4 then. So these are all 1 through 4. This is 1 through 4. This is 1 through 4. Therefore, this has to be 1 through 5. to form a Renban correctly. The circles, again, they have to have at least two. And it could be up to three. Yeah, it's two or three, remember. This is two or three. Interesting. The rest of this row cannot be one or two. So this is 3, 4, 3 through 9. Oh, interesting. This must have at least one of these two in its region. Oh, that doesn't mean anything. Never mind. That doesn't impose any constraints there. This is 2 or 3. Can this ever be in the same region as these two? Or either of them, I should say. Maybe. Well, okay, let's say it's these three and it's trying to get to this one, right? How do you connect? One, you need to connect this way. And this requires 3 more either way. So how many is that? 5, 6, 7, 8, 9, 10. So no. So we know, okay, that's interesting. This green region, oh. Okay. This green region can never be in the same region as the corner regions. So then we can make this red and this one light gray or white. Because we tried just making it with 3. It doesn't work. Also, we know these share a region or share a cell, right? So this can be a knight's move away is here. This can be a knight's move away is here. We know one of these is 1 and one of these is 2. But if both of them took the knight's move, this would only have 2 cells, which it could be part of the same region then, because we've proven that these cells, green can never be with light gray or red. So there, it cannot be in the same region as that. Therefore, only one of these can be taken by one of these, but one of them does have to be taken by one of them because one of them is 2, right? This sees only 2. So if this were 2, it takes that one. Therefore, this one would have to be 3 and take these 3. Similarly, if that's 2, it would have to be both of those are taken by the white, and therefore the green would have to take this one, which would be green, and therefore this would be taken as red. So we know red always takes this one, white always takes that one, and green always takes these 2. In addition, we know this has to be 3 then, because we know it takes one or one of the other. So this is either light or green, and this is either green or red. We're not sure which, right? So this cannot take that one, so this can never be 4 then. It could take these 3 though. So that's possible. Therefore, this is always part of the same region as that. Well, we know all the circles are always 3 through whatever, right? Because it contains the sum of 2 digits that are in its own region. So this could be 3 through 9. So the rest of this, of column 1, has to be 4 through 9. This is 4 through 9. Yeah, that's not helpful. Let's leave that for now. This is 1 or 2. This is 1 or 2. Hmm. uh, what else do we have here? Hmm. What else do we have? Hmm. If, okay, this is interesting. This contains, hmm. Hmm. Can this ever be green? I think so, right? You could have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So that could be green. So this almost has to be green or red, right? If it's not, how does this even... Yeah, I don't think that that could... I don't... Well, yeah, this can't exit out anywhere else, right? So this is green or red, right? Where does it actually enter in? So say this was some other color. Say it was like blue. If this is blue, the red has to connect this way, so obviously it would have to go here. But then that blocks off blue from going anywhere here. Therefore, this is either red or green. If it's green, then you have problems because then you have to go through here, and then the green has to go around here somehow, which doesn't work. If it's red, you have the same problem because you have to go around. I guess it's possible, maybe. This is too much though. Like say, okay, 1, 2, 3, 4, 5, 6. This 8, right? This is already 1, 2, 3, 4, 5, 6, 7, 8, 9 to connect these, so that's not possible. So yeah, so this can't be anything but green or red. So that's green or red. This then also has to be green or red because of the same problem. This could be green or red, right? This could be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. That's possible. Unlikely though. So these are all green or lights because of the same reasoning. Green or white. We're gonna say it's white, right? What about this one? This one actually could be some other color, right? You just go here, and then red has to go here. Hmm. Um. Hmm. 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 Uh, this can be 3 through 9 because they add up to 2 digits. Well, all the circles are 3 through 9 essentially. Hmm. This could be green, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's fine. And that could be green even too, technically. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think it's green though. This doesn't seem very greenish. Um, could this be red? Yes, it could be red. Because it could be 1 and 2. Yeah, the only reason this couldn't be 1 and 2 was basically because you had to have 3 at least here. But this could be 1 and 2 here. Hmm. So these could all be part of the same region. That would be 2. Or this could be 1 even. And then this would be 2. 5, 6, 7, 8. Okay. Hmm. Oh, interesting. Huh. Oh, interesting. What happens with circles that are a knight's move away from each other? That would mean this has to be the sum of this circle with another digit, but then this would have to be the sum of this circle with another digit. And therefore, they would both have to add up to each other without, and they are in the same region then, if that's this assumption. So therefore, from that assumption, we cannot have any circles that our knights move apart from each other be in the same region. That is very cool, actually. That is very, yeah, that's very interesting. So no circles can be. Obviously, circles and squares could be because they don't have the same mechanic. But circles with this another circle cannot be in the same region. Therefore, we're going to start making the circles. I'm going to make these different. So this will be the green circle. This has to be a red circle, or a red circle. We're going to make this one pink. These all have to be in a different region. I guess this could be in the same region, but it's too far. Well, maybe. We're gonna make this yellow, and then this blue, and then this orange, and then this, I don't know, make it dark. Now, as long as they're not a knight's move away, they don't have to be in different regions. But interestingly enough, this yellow sees 3 already. So these 3 specific, well, these could be in the same region together, technically. But this one cannot be in the same region as these three, right? What does that tell us? I'm not sure, but it does tell us something. Oh, well, one thing it does tell us is that this, again, has to have at least two. So it has to contain, it has to have at least two that are in the same region, because it can't be one and it can't be zero, obviously. Because zero would add up to zero, one would add up to the same digit, but they're in the same region, and that's not allowed. Therefore, it has to be at least two. So out of these three cells, it has to be in the same region as two of them. At least. It could be three. It could be all three. Because it doesn't have any more here. Right? Oh. That tells us a lot, actually. That tells us a lot. This one has two cells that it can't be part of. And we know each circle must have two digits that it adds up to. Because otherwise, if it's one, again, if it's zero, it adds up to zero, which is not a normal Sudoku digit. And if it's one digit, it's the same as that digit then. And they're in the same region, which is not allowed by the chaos construction rules. Therefore, this must be the same region as both of these. And if it's green here, say this was green. Say we tried to make this green. It doesn't work, right? Say, because it breaks this region, because this one wouldn't work. Yeah, it would just have to basically cover here, then here, maybe here, this way. This is already 5 here. That's 6, 7, 8, 9, and that's 10. So this can't be green ever. So this has to be part of red, which makes this part of red then. And this then also has to be part of red. So this is the sum of these two numbers. It cannot be 3 because we already have a 1 or 2 here. This sees at least 1 or 2. This cannot be any other color because it breaks up the red. So this has to be red. So we have 1, 2, 3, 4, 5. We need 1 to connect to here. So that would be 6 and 7. Oh, this can't be the same region as this one. So therefore, this has to be the green. Which means this can't be green. This has to be light. So this is the green, this is green, this is green, which means this can't be 3. So this adds up to one of these two, at least. So this is 1, 2, 3, 4, 5. This is only 1 then. So this has to be a 1, which means this cannot be 1. This has to see at least 2. It sees that one. 1, 2, 3, 4. It cannot see this one. This can't be 1. Actually, I guess these could be in the same region, thinking about it. So this is not 1, so this is at least 5, because it would have to be 2 and 3 and 2 and 3 at least. Actually, this can't be, this has to be 2 then. So this is at least 4. So we have 2 and 4 at least, so this can't be 5. This could be 5. It could be up to 7. 4, 5, 6, 7. So we have these 5, which are in the same region. This one has to see at least 2. So it sees that one. It could potentially see that one. Okay, can these be in the same region as this then? So we have 1, 2, 3, 4, 5, 6, 7. If this is the same region, it would have to be 8 and 9. But then this would only see, this would only see 2 in the same region, and this would see only 2 in the same region. Therefore, these cannot be in the same region. Therefore, this is a different region. We're going to make it yellow. So this one cannot see this one. What else can it see here? 1, 2, 3, 4, 5, 6, 7. If we have 8 and 9, that's possible. Or we could have... Can we ever have more than that? So this is 6, 7, 8, and this would be 9. So no, this always has to be 2. So this is 2 then. Which means this is 4, 5, 6, or 7 with 6, 7, or 8, or 9. This can't be 2. So this sees either... So either we see this one or we see this one. We're not sure which. This one can't see any of these. It could see either of these two. Oh, can't be there because this is a different region. So this has to be a different region than this because of the problem that we ran into. So therefore, this must be green because it must be adding up to this. This obviously can't be 6 because it's 2 digits now. So this is 2 digits adding up to it. So this is 1, 2, and it could be 4, 5, or 6 to add up to it. Therefore, this has to be either 1, 2, 3, 4, 5, 6, 7 to be a red band line. This is 2. So this sees 2. It's either here or it's here. Both are valid. This does not see any of these two because it's a different region. Because we tried to make it the same region but as red, but it doesn't work. So therefore, this must be 2 also. So these 2 must be yellow. So this one sees 2. It's yellow. What does this see? It's 1, 3, or 4. Huh. Could be yellow. That's fine. This is in a different region as this. It just is in a different region as that. And this cannot... This could be red, actually. We're not sure. This actually could be red. How does it be red? It could be something like this. So 1, 2, 3, 4, 5. No, it can't be that. 1, 2, 3. So if it's part of red, it's 1, 2, 3, 4, 5, 6, 7, 8. And this requires another one to make it 2. But this also requires another 1 and knights move away. And they cannot be the same one. So this one cannot be red. This one has to be a different color. So it could be pink. It's not the same as this one, though. So we're going to make that pink. We don't know which way it exits out. So this is different from the green. So these two are the same. This still could be 1, 2, 3, 4, 5, 6, 7, 8, 9. That could work. No, it can't. This one cannot be red. If this were red, the problem is that the 2 doesn't have 2 knights moves away that are in the same region. So this one cannot be red. Therefore, this is green. So we have 1, 2, 3, 4, 5, 6 greens already. So we only have 3 left for the other greens. So this one cannot be green then, right? Because we have 1, 2, 3, 4, 5, 6. We need to connect still 1. So this is at minimum 1, 2, 3, 4, 5, 6, 7. So then these could be green, but that can't be green. Therefore, this is white. So we know this is white. This is white. It could go this way though, so that's fine. So these could be different colors, different regions. What else do we have? Digit inside a circle equals the sum. So this is the sum, right? That's fine. This cannot be 3 because it's the same region. So this could be 1 and 2 specifically, or 4 and 5. It can never be 2 and 3. Neither of these can be 2. This could be red. Okay, so say we had the red continue on here, right? Say we had the red be this one, right? What does that mean then? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, if that's the case. But then, okay, actually, no, it can't be red there. This can't be red. This is a different color than this. Therefore, this is not possible. What about going up? 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't reach that one. So this must be red. So we know that's red. So this is 6. We have another red in one of these two spots. So that's 7. This is 8. This could be 9. So the red cannot be here. It's probably yellow, but it could be a different color. So we're going to make this yellow and some other color, but we're thinking this is yellow. This is yellow or blue, same thing. So these could be red, or they could be yellow, or the gray. This could be red. Cannot be yellow. It could be red or green. This is only red or green then. So red could technically, so if we tried to make red here, we know we tried making red here, that's not possible. What if we tried making red here? This would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But the problem is only one other thing is in this region. Therefore, this cannot be red. So red has to be one of these 4 cells. Actually, one of these 2, or it could be both of them. It has to be 2 out of these 4 cells. So that's what red has to be, right? So first of all, let's start making boundaries. So we know this is a boundary. We know this is a boundary, and this has to be a boundary. What else do we have? This sees both of those too. Okay. What about this one? If this is not yellow, obviously it can't be red. It can't be the same as this one. So where would the digits be that would add up? It would have to be these 2. So far that looks okay, right? It would just be the sum of those 2. So that's fine. Oh, wait. We know this has to be the same as those 2. This can't be the same region as this. It can't be the same region as those 2. It can't be the same region as that. What's left? It has to be one of these 2. Huh. Oh, what about this one? What region is this one in? It can't be the same region as this one. It could be there. It can't be the same region as there. It has to then be the same region as these 2. So these 2 have to be the same region then as this. We know this is also the same region as that, therefore this has to be the yellow. So therefore this does have to be a different color. So we know this is, we're going to make this one pink then, and this one's going to be, I guess we can make this blue. Let's stick it this way then. This could be pink. No, wait. We're going to make this one blue because we know 1, 2, 3. So we connect this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, it has to be that. So, This is interesting. Okay, so we're going to just make this, okay. This has to be the same color as these 2 because this can never add up to just one of these. These 2 have to be the same. The thing is, this has to be in the same region, right? Because if this is not, this is blocking this, and this can't ever form a region by itself. So this has to be yellow. 1, 2, 3, 4, 5, 6. So this has to connect some way to here. This has to connect some way to here. And this has to connect some way to these two. So that's 1. One of these two is connecting. This one can only connect one of these two. And this one connects only one of these two. Right? To connect the whole thing. Therefore, I'm making this blue. Because we know it's the bottom right corner. So it cannot be... If this one's blue, that one can't be any color. So therefore, this has to be the blue. Similarly, if this one's blue and it connects this way or this way, these can't be any other color. So this cannot work. So therefore, this has to be the blue. And we connect either here or here. So therefore, we're going to make this yellow. One of these or both of them can be red. Well, this can't be... One of these is blue. So this is blue. But this can't be blue because of this one, right? This has to be the same color as this. So therefore, this is not blue. Therefore, this is yellow. Therefore, we have the whole blue structure. Because these two have to be in the same region as this one. These two have to be in the same region as this one. And the only way that, therefore, these are the same region, therefore, it can only connect this way. This has to be yellow. This has to be yellow. The only way to connect to yellow is through here. So therefore, this is yellow. This could be red and red, though, here. We're not sure. So specifically... Again, we have this region already. The blue region is completely done. So this is a full region by itself. So then we know this adds up to what these two add up to. It cannot be 3 because there would have to be 1 and 2 it adds up to, and that's not possible. It could be 4 through 9, though, so that's fine. This... cannot see any of these. It could be that one. That's fine. So this cannot be blue. It's only red or yellow. So these are only red or yellow. Interesting. This then has to be pink because it cannot be the same as yellow. So it has to go up. It can't be green because of the same reasoning, because of that. This could actually be yellow. So we don't know. This sees those two, and 2 could be here. Wait, why did I make... That's not red, that's pink. So this is not part of the yellow region. This is not part... Okay, so we know also these are boundaries. The pink also requires at least 2. It cannot go in here. This can only be green or white. This can only be green or white, too. And this could be green or white. Cannot be red. It's either green or white. So these cannot be the same color as pink, the same region as pink. Therefore, it has to add up to 2 of them. It has to be just those 2. So those 2 are pink. Which means this is a border. This can't be 3 because of this 3. What else do we know? This sees 2 cells. This, well, This sees 2. At least. This one could actually be the same as this. We don't know. This, okay. Right. So how many cells can this see? It can't see any of those cells anymore. It can't be any of these. It can only be this one or this one, right? It cannot be 2, so it can't be both. So therefore, this has to be 1. Now the question, though, okay, so this can't be 3 anymore because then this can't be 1. So this is at least 3, and this is at least 2. So therefore, this is at least 5 here. Now the problem is, which one is it? It can't go any more here, right? This is yellow or pink. But the problem is that it has to extend more, right? So therefore, this has to be yellow, which means this can't be yellow. This has to be red. So this is 1, 2, 3, 4, 5, 6, 7. This is 8, so this can't be red. This has to be green, which means this can no longer be green, so that has to be white. So we have 1, 2, 3, 4, 5, 6, 7 already for green, right? This cannot be this way, right? So this can't close out that way. So we know this one is no longer... So this is a boundary, too. We know this is a boundary. Let's just put the whole edge a boundary. So one of these is red. We're not sure which to connect to the 2. This cannot be yellow because we know that has to be the yellow. So this is 1, 2, 3, 4, 5, 6, right? Because if we try to make this yellow, this is at most 1, 2, 3, 4, 5, 6, 7, 8, but then it can't connect. So therefore, this has to be yellow, which means this can't be yellow, so this is red. We have 7 greens here. So if we try to make both of these green, or both of these green, the problem is, what is this color? It can't be, it would have to be green, but then green would be 10. So this one can never be green. Therefore, this is light. We have 1, 2, 3, 4, 5, 6 lights now. If we tried to make this 7, 8, I guess it still could, actually. That could be the case. So this still could be light. And it could connect this way. 1, 2, 3, 4, 5, 6, 7, 8, and then it could be 9 there or something like that. That's fine. This is 2. It sees 2. That's fine. This is 1. It sees only that one. This could be yellow. In which case, this would be yellow. So this would be 1, 2, 3, 4, 5, 6, 7, 8. It could contain a 9 here. So that could be yellow still. These are different colors, though, no matter what. But this could be yellow here. These are different colors. Could be something like that. This one could be pink. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's fine. These are not the same number, though, interestingly enough. Okay, so this is the sum of these. So this has to be at least 3. This could be 1. So this is 3, 4, 5, 6, 7, 8. This is 3. This has to be 3 through 7. Because this can only be 2 at most. So this is 3 through 7. This is 2 through 6 to add up to 9 at most. This could be 1, 3, 4, 5, 6, but that's it, because this has to add up to 9 at most, and this is 3 at minimum. This one. What can this be? This can't be part of blue, so therefore none of these are allowed to be part of its region. This one can't be part of its region because of what we established about the circles before. Therefore, it must have 2, and it must be these 2, and therefore this is part of yellow. So this is part of yellow, which forces this to be part of yellow to basically maintain that. And we're going to make this orange then, because it has to be a different region. So this is 1, 2, 3, 4, 5, 6, 7, 8. And this one, what region does that have to be? It can't be blue, and it can't be any other region besides yellow. So therefore, this is yellow. So now we have the full region, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 yellows. So we have the full region of yellow. So it has to be this, which means that this can no longer be yellow, so this must be red. This can't be red then, so it must be green. So now we have all the reds, because that's 9. And we have 8 of the greens. So this is 1, 2, 3, 4, 5, 6, 7, 8. If this were green, that would block this from being any color. So this cannot be green. So either that has to be white. So we have 1, 2, 3, 4, 5, 6, 7, and then 8. So one of these is white. One of these has to be white to basically connect with this one, to make it orthogonally connected. And we know one of these is white. So that's 1, 2, 3, 4, 5, 6. This is 7. One of these is 8. And then one of these is 9. Because only one of these can be green. Not both, right? Because we already have 8 greens. Therefore, the white has to be one of these two. This cannot be white, so it has to be some other color. We're going to make that gray. These could be gray. This could be gray or pink. So this one's fine. Therefore, we know what the green is in terms of everything else. So it has to be that, and this one's a border, but we don't know about one of these two, right? And one of these has to be white, and one of these has to be green. So this is white. It sees 2. It does. That's all it sees. So this cannot be 3 because it would have to add up to 1 and 2. That's not possible. This has to be at least 4, so this can't be 4 then. This could be 1. It can't be 2. Could be 3. This is 4, 5, 6, 7, 8. Because it could add up to 9. This is 1, 3. Could be 4, 5, and that's it. So this is 5 through 9. This cannot be 2. Therefore, it can be 3 or above to be in a Ren band with 5 or above. But it can't be 2 because of this 2. Okay, so this can't be yellow, therefore it's pink. So we have 5 pinks now. This orange must be the sum of 2 digits, therefore it has to be both of those. So those are orange. Can this ever be another color? No, because it has to exit out this way. So therefore, and then that would block essentially both oranges from connecting to there in an orthogonally connected region. So therefore, this is orange. And since this is orange, that blocks off the rest of these cells. So therefore, these all must be orange because they can't connect orthogonally to another region that has 9 digits. This is the sum of these 2 digits. So this has to be at least 5. So this could be 2, 3, 4, 5, 6, 7. Can't be 3, though. Could be 2 and 7, though. That's fine. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Can this ever be connected to either of these 3 cells? No, because we have 8 already. So this one only sees this cell. So therefore this only sees 1. It has to be 1, which means this cannot be 1. And this has to be 2 and 3 because of how we described it earlier. Interesting. So this is 2 or 3 because of the Renban line. And this has to be 2 or 3. This cannot be orange because if it were orange, it would only see one other cell in the Knight's Move away from its region. It could be pink. So this could be pink. Or it could be dark, or it could be medium. But it cannot be orange. So this is any of those. This adds up. This adds up to 1. So the regions that it sees. This sees both 2 and 3, so this can't be 2 or 3. This has to be at least 4. 4, 5, 6, 7, 8. Well, it can't be 8. This is 4, 5, 6, or 7, so this cannot be 4 or 5 because it has to add up with a 2 at least. This could be 2, 3, 4. It could be 4 and 5, or 5. And those are the only possibilities there. So this could be orange, this could be orange, this could be orange. Those are the only possibilities there. So we know this is a separate region. This has to be a separate... actually, this could be... No, if this is orange, that can't be part of any region. So this one can't be part of orange. So this is part of dark. We're going to make this dark and dark. So we don't need those anymore. Well, we kind of maybe do. I don't know. This sees both of these two. This sees both of those two. This sees both of those two. This sees those two. Okay, this sees those two, and this sees those two. Okay. If this were 6, then, say this was 6, this would have to be 3 to add up to 9, and this would have to be 2. But then we would have a 3 and a 2 in column 7, which would eliminate all the possibilities here. So this can never be 6 then. Hmm. Hmm. What else do we have? So this is not part of orange. I guess it could be black here. So this is green. This is orange or dark. Black, we're going to make it. Let's call it. This can't be pink, I don't think. Actually, it can't be gray. Can it? 1, 2, 3, 4, 5, 6, 7, 8. I guess it could be gray, actually. And then that's 9. That's possible. Okay. Anyways, this is the sum of those two. This can't be 1, but this... And it can't be 2, so this is at least 3. This could be 1, though. So this can't be 3. This is 3 through 8, and this is 1 through 6, but no 3, obviously. Yeah. This sees only 1. What about this? This sees 1. This sees 2 or 3. Interesting. Okay. What regions do they have? So this has 5. Can this be light? No. Could it be pink? It could be pink. So it could be pink, it can't be light, could be medium. Can it be dark? Yeah, it could be dark technically. I'm not sure though. So this could be green, sorry, orange, pink, dark, or medium. This obviously could be pink because then it could be 2. So this would be 5. This would be 6, 7, at least 8. And then it could be another one, 9. This could be definitely dark because 1, 2, 3, 4, 5. Okay, so this is orange, pink. It could be medium, and technically it could be dark. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9. Technically it could be dark. So yeah, that could be dark also. Oof. This can't be pink, though. right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has to be either dark, medium, or orange. So those are all the orange possibilities. One of those has to be orange. We know this is a boundary. We know these two are boundaries. And then this is the question, right? So this is a 2. Ah, where is the 2 in row 8? It cannot be in any of the blues or the reds. And it can't be here because this can't 2 can't be the sum of 2 unique digits. Therefore, this must be a 2. Oh, that's interesting. So this can't be 2 anymore. Huh. Interesting. Okay, so that's 2. This is 2. This is 2. Where's the 1 in row 8? Can't be in the reds. Can't be in the yellows. It must be one of the blues. Okay, that doesn't limit us very much. So one of those is 1. Okay, so that's 2. Hmm. So, huh. Hmm. Where? No. Okay. I think that's all we have there. This can't be 2 anymore. Therefore, this has to be a 3, which forces this to be 2. Okay, which means this can't be 2. So these cannot add up to anything but 7 at least. So this has to be 7, 8, or 9. This is 2. So this sees 2 specifically. Okay. What does that mean? I'm not really sure. Two, 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 two. It could just see those pink ones. It could see. So if this is orange, it could just be those black ones, potentially. Yeah. Or it could just be the 2 medium ones there. So that doesn't limit things, unfortunately. This can't be 3 though. Wait, say this was pink. So if this is 1, 2, 3, 4, 5, you could only connect, so okay, 6, 7, 8. I guess it could connect that way. That would be 9. No, because this has to be light, medium, or pink. So if this were pink, okay, so if this is pink, this could still be light. But this could not be. So this is pink, medium, or potentially dark. This could be pink, medium, or dark? Dark is a little weird. If this is dark, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the pink would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's possible. Yeah, it could be dark. Interesting. This can't be light. It could be dark or pink. If it's pink, then this would have to be pink. Yeah, okay, let's say this were pink, right? How... Oh... If this is pink, that means this can't be pink anymore, and it can't be medium, because it can't connect anymore through there. Therefore, it's light. Therefore, this is medium. So this would be light, and this one could not be light anymore. It would have to connect to pink. Therefore, this would have to be pink, and that would have to be pink. So then this would be 1, 2, 3, 4, 5, 6, 7, 8. But the problem is that you can't connect this to any of the other knight's moves. So this cannot be pink. So this is either medium or dark. Right? So if we tried to make this pink, that means this can't be pink anymore. So one of these, and this can't be medium, because the medium is only by going around. Therefore, it would have to be light, which would force that to be medium. And then, therefore, what could this be? This couldn't be light, because we already have our 9 for the light. And it can't be medium or dark, because the pink would have to either block it or go through it. So therefore, it's pink. Therefore, this is pink, this is pink. Therefore, we can't get, again, we cannot connect then to another cell that's a knight's move away from here to be pink. So therefore, this is medium or it's dark. This still actually could be dark, though. This could be those 9, right? So if we tried to make this dark, so say we made this dark, right? This needs 2 that are knight's move away from it, but then it has 0 that's a knight's move away. So this cannot be dark, and I think that similarly this can't be dark either, right? So say this was a knight's move away. So say you had this, so the 1, 2, 3, 4, 5, 6, 7, 8. This is required for the dark. The problem is only one of these can be dark, and that's the only ones that are knight's move in the same region away. So this can't be dark either. So this is pink or medium. We're not sure which. So if these are medium, this one has to be medium, right? If this is medium, this has to be medium, which forces that to be medium. Because if it's dark, then you block it from its region orthogonally. So that one doesn't work. So therefore, if this is medium, then you have all of these be medium, right? If this is medium, this must be medium, which means that must be medium too, right? So therefore, it's 1, 2, 3, 4, 5, 6. You could have 7, 8, or 7, 8. So those are both fine. So again, so this, the rest of the cells can sort of be pink, medium, or dark, right? This can't be pink, though, because this is more than 4 away from here. So 1, 2, 3, 4. I mean, it is 4 away, but the problem is that it would block. Okay, so this has to be medium. Right, this has to be medium. This could connect this way, but can it be pink is the question, right? If it's pink, 1, 2, 3, 4, 5, you could have 6, 7, 8. It would have to be 1, 2, 3, 4, 5, 6, 7, 8, or something like that. As long as 1, 2, 3, 4, 5, 6. You can't go that way. 1, 2, 3, 4, 5. It has to be 6, 7, 8. If that's the case. But then this would be 1, 2, 3, 4, 5, 6, 7 at most. And that can't work. Therefore, this can't be pink. It could be dark, though. This can't be pink, obviously. It's too far away. So this is medium or dark. This can't be pink. So we can go 1, 2, 3, 4. So these can, this one could be, but these can't be. Okay. This cannot be 3. If this is 3, the problem is where are the 3's then in rows 8 and 9? It can't be in any of the blues, and this can only be 1. Therefore, this cannot be 3. This has to be at least 4, so therefore this can't be 4. This is at least 5. Okay, so this can't be 6 anymore. This is 1, 3, or 4, or 5. Because if it's 6, that would be at minimum 4. That adds up to 10, which this digit doesn't allow. 2 and whatever that is. Where is a 3 in row 7? It cannot be in the green, can't be in the red, or these specific spots, so it has to be either here or here. If this is 3, this cannot be 3. Because of the chaos construction Sudoku rules. If this is 3, this again cannot be 3 because of the chaos construction rule region part. So this can never be 3, which means this is 4 or 5, and this has to be at most 4 or 5 to add up to 9, because these two can only be 4 and 5, and therefore this is not. So these two are the same regions, 4 and 5, 4 and 5. 3 could be here, or 3 could be here. We're not sure which. So this is 4 and 5, 4 and 5. This could be 3, cannot be 4 or 5, can't be 2, so it's 6, 7, or 8. 3, 6, 7, or 8. This can't be 2. It could be, this can't be 3. This is 4, 5, 6, 7, 8. But it can't be 4, 5 because we have a 4, 5, 4, 5 pair in this region. So this is 6, 7, or 8. This could be 2, 3, 6, 7, or 8. So that's fine. So this is 4, 5, and this is 4, 5. We don't know about 3. 3 could still be one of these cells. Oh, okay. Where is the 3? Oh, there we go. Where is the 3 in row 6 now? It can't be any of these cells. This one can't work because it cannot be 1 and 3. It cannot add up to 1 and 2. It can't include 1 and 2 to add up to 3. 3 could be here, or it could be here. So it's in the yellow, or it's in the orange region. We know in row 7, the 3 has to be in the yellow or orange region, which means that yellow and orange can no longer have a 3 in the rest of their regions. Therefore, this cannot be orange. This has to be dark or medium. Therefore, the orange is one of these two cells, and it cannot be... Yeah. So either this is 3 or 1. So one of these two has to be 3. Then we know that for certain. Because either this is 3 or this, or one of these 3 is 3, right? For row 6. This is 9, this is 4, 5. This can't be 3 anymore. It cannot be 1 or 9. It could be 2. It could be 4, 5, 6, 7, or 8. That's still very wide. Okay. If this is not 3, that doesn't work. So say this was 3. Say neither of these are 3. Then the minimum these two could add up to would be 9. And that would have to be 4, 5, 4, 5. But then 4, 5 is no longer allowed here. So this would be at minimum 4 and 6, which would add up to 10. And therefore that would not be a digit. So 3 has to be one of these two. So this can't be 3 and this can't be 3. One of these has to be 3. This can't be 7 obviously anymore because we don't have a 2 to go add it to add up to 9. If this is 3, this could be 4 and 6, or it could be 5 and 6. We don't know which. This can't be 7 either. If this is 3, then this has to be 4 and 5, 4, 5, right? So then this could be 9. That could be possible. So this is also 4, 5, 6, 7, 8, 9. This is also 4, 5, 6, 7, 8, 9. Huh. This is 4 through 9. This is 4 through 9, right? Let's see. This can no longer be 5. This can no longer be 5 because it's at minimum 3 and 4. Right? So this could be 3 and 4. This could be 3 and 4. This can't be 1 anymore. Since that can't be 1, this is at minimum 3 plus 4 for these two cells. So therefore, this is also 7, 8, or 9. So in a random band with 7, 8, or 7 as the lowest one, you could have 6, 5, and 4. So this cannot be 3. This is also 4, 5, 6, 7, 8, 9. This is also 4, 5, 6, 7, 8, 9 because you can only have 4 at the minimum in that random band. This can't be 1 anymore. So since this can't be 1, this can't be 2. Okay. Therefore, this can't be 5 to add up to, because it can't be 2 and 3 anymore. This adds up with these two. That's fine. This could be a lot of numbers. This. These two. This is these two. This is those two. This is these two. Oh. So since... Wait. Oh. This sees 3. So this has to be 9. Okay. Well, there you go. And this is 3. This is 4. Which forces this to be 5 and that 4. So 4 is no longer allowed here. Interestingly enough. This is 5 or 6, so this can no longer be 5. This can't be... Yeah, so then that makes that easy. Therefore, this has to be 6, 7, or 8. And this is 6, 7, or 8. This can't be 4 anymore. What can this be? It's 6, 7, 8, 6, 7, 8, 6, 7, 8. This can't be 9. Right. I totally missed that. Jeez. Oh. Anyways. This can't be 4 anymore, so this can't be 6. We need a 1. 1 cannot be here. 1 could be here or here. Or here. So this is 5 through 9. This is 5 through 9. This is 5 through 9. This can't be 3 or 4 anymore. So therefore, this has to be at least 1 and 5. So therefore, that's 6. And the way I know that this can't be... this didn't affect it, was that basically I just only eliminated what these two numbers could add up to, right? But I didn't take into account that one at all, so therefore it only eliminated... So this cannot be 6, 7, 8, or not. No, it could be 6, 7, or 8. This can't be 9, though. We know... Yeah, we don't know what those two are. This one... Okay, so the borders we know are here, here, and here. We don't know anything else, though. This can't be 9. So this can't be 9, which means this can't be 7 specifically. This can't be 5. There's no 5 here. There's no 5 here. So 4 has to be one of these two cells. right? Because this can't be 4, these can't be 4. The 4 can only be one of these two cells. So 4 can never be here. Oh, also 4 can't be here either. Where? Right. Whatever this digit is, where is this digit in rows 8 and 9? It has to be one of the ones in the red cell, and it cannot be any of the ones in the blue cell, right? So say, okay, so if whatever this digit is cannot be here in row 9. So it has to be one of these 3 cells in row 9. In addition, therefore, it cannot be in the red cells in row 8, and it can't be in the blue cells in row 8, and it can't be the 2. So this has to match up with this cell specifically. So therefore, and it cannot be 9. Why can't it be 9? I don't know why it can't be 9. Well, it can't be 4, 5, and 6. That's for certain. So it's 7 or 8. And maybe 9? Why can't it be 9? Oh, because it adds up with 2 digits to add up to this digit. So this is 7 or 8, which means this is 7 or 8, which means this has to be 8 and 9, which means this has to be a 1, because this can't be... If this were a 3, at minimum this would be 3 plus 7, which would be 10, which is not allowed. So therefore this is a 1. These can't be 1 anymore. This is 7 and 8, or 8 and 9, which means in the rest of this blue region, you cannot have an 8. Because either this is 1 and this is 7, which adds up to 8, or this is 1 and this is 8 and it adds up to 9. Therefore, this cannot be 8 here. Okay, so since this is 7 or 8, it must contain a 3. Because if it were 4 and something, you can only... Well, I guess it could be 4... yeah, well, we already knew it contained a 3. So this is either 3 and 4, or it's 3 and 5. Therefore, this can't be 6. This can't be 7 anymore, because this is at least 3 and 5. So therefore, this is, yeah, at least 3 and 5. It could be 4 and 5, or it could be 3 and 6. If this is 6 and 3, this must be 5, which makes this a 9, makes that an 8. If it's not a 6, this is 5, which forces this to be... Okay, yeah, what are the possibilities then? So say this is 3 and 4. This then could be a 5, or it could be a 6, actually. Then this could be 8 or 9. Where is the 1 in row 6? It cannot be any of these, obviously. It can't be this, so it must be one of these two. We're not sure which, though. Hmm. These are the same digit. But what does that tell us? I'm not sure. This could still be 4. And this would be 1 if that's the case. Otherwise, it's 7, 8, or 9. That's interesting. Why can't this be 2 again? I don't remember. Oh, because this can't be 1. Right, so this could still be 1, 2. Or it's 6 with 5 or 7. This can't be 4 anymore. This is 2, 5, 6, 7, 8, 9. This is 2, 5, 6, 7, 8, 9, but no 2 because of that 2. 2 cannot be here. Interesting. Where is the 2? The 2 could be one of these two, or it could be this one. So the only way this is not 1 and 2 is if they are here, right? And they would both have to be green. This can't be 3, 1, or 2. This is 4, 5, 6, 7, 8, 9. Where is 3 in the red? It has to be one of those 3. Because it can't be in rows 1 or 2. This is 5 or 6. Interesting. Hmm. Oh. This, well, it's possible. This can't be 6 anymore, or 5, because then the minimum would be here, would be 11 or 10. Or it would have to be 11 twice. So this can't be 5 or 6. This has to be 1, 2, or 4. Um... Ah, one thing we see. Where's the 4 in row 7? Can't be any of these anymore. Can't be this one because of the orange cell. Can't be these. It must be one of these two. So therefore, the rest of the green region cannot contain a 4. So this can't be 4, which means this can't be 7, which means that doesn't mean anything. I thought it meant something, but no, it doesn't actually mean anything. Never mind. Hmm. Hmm. The 2 has to be one of these 3 also, but that doesn't really tell us much. Hmm. Because, oh, this can't be 2. Where's the 2? Where's the 2 in row 5? Can't be in the green region, because this one specifically can't be 2, because this can't be 1 or 3. Can't be in the white region, because we already have a 2. Can't be any of these, because we see it by Sudoku, and then this is a 9. So the 2 has to be here, which means this can no longer be pink, because you can't have 2 2s in the pink region. Therefore, yeah. So we know 2 is one of these 3 cells in the pink region. So this is also medium or dark still. They could be in different regions, though. So then, interesting. What does that mean? These 2 are the same digit. Let's just mark that with, I don't know, I'm going to make it a green circle. Those are the same. It doesn't have to be the same as this. It could be different. Could be here, could be here. Hmm. What else do we have? Okay, so if this is 4, this has to be 1, obviously. Then that has to be 2. So that's fine. So if this is 4, this is 1 and 2. If this is 8 or 9, though, this has to be 8 and 9. We have an 8, 9, 8, 9 pair then in row 7. So the rest of the row cannot be 8 or 9. Therefore, this would have to be 7. This would be 7 then, and therefore this would have to be 3 and 4, which would force this to be 5 and that to be 9, and therefore this would have to be 8. But since this is 8, this would have to be 3 and 5, which we already have a 5 there. Therefore, this cannot be 8 or 9. It has to be then 4. Therefore, this is 4, which means this can't be 4. This has to be then a 1, which is consecutive with 2. So these can't be 1 anymore. This can't be 1. This has to be a 1 because that's the only place left in row 6, which means it cannot be green because you can't have duplicates. Therefore, it's white. Therefore, this can't be white and must be green also. So now we have the boundaries between green and white. Oops. So therefore, this is a boundary and this is a boundary. So this is 1. 2 can no longer be here. Therefore, where is the 2 in row 6? It has to be here. So this is 2, which means this can't be 3 anymore. Therefore, this has to be the 3. So this is 3. This has to be 3, which makes this 5 and this 6. This 5 and 3 add up to 8. So this is 8, which means this is 8, which means this is 9. This 3 and 6 add up to 9, so this is 9. Therefore, you cannot have 5, 6, 8, or 9 here. This has to be in the yellow region because we already have those, so this is 7 and this is 4. This can't be 5, 8, or 9. It cannot be 4. Therefore, this can't be 5, 8, or 9, so this is a 6, 7, 6, 7 pair in the green region, so the green region cannot contain a 6 or a 7. So this has to be 5, 8, and 9. This is 5, 8, or 9, and this has to be 5, 8, or 9. This can't be 7. This can't be 7. This can't be 6. This can't be 2. This can't be 9. Let's see. So we know 2 is one of those 3. This has to be 5, 6, 7, or 8. It cannot be 9 because of that 9 in the light region. So these are the same. Okay, so then we can remove this because we know those are good. The 8 has to be one of these 3 cells here. We're not sure which. Oops, not all of them though. So one of them's 8. This can't be 6 anymore because of this 6. 9 has to be one of these 2 cells in the red because this can't add up to anything, so therefore it can't be 9. And this can't be 9 because of this 9. So this becomes what? 3, 4, 5, 6, 7. This can't be 9. Therefore, one of these 2 is not. Okay, so we already knew that, though. This is 3 through 7. This is 3, 4, 5, 6, 7, 8. This can't be 2. But that's it. This can't be 1, 2. So it can't be 2. Can't be 1, 2, 3, 4. It could be 5. Can't be 6. Could be 7. Can't be 8. So this is 5 or 7. This can't be 8 anymore. So since this can't be, well, this still could be 1 and 7, which would add us up to 8, so that's fine. This is 2 or this is 2. This can't be 1, so this can't be 1 here. Well, that doesn't change anything, really. It does change the minimum, so this can't be 6 anymore. So this has to be 8 or 9, right? So because the minimum would be 2 and 5. This can't be 2 anymore, so this is 5, 6, 7, 8, 9. So this is at minimum, it could be 2 and 6, which would add up to 8. It could be 2 and 7, which adds up to 9. It could be 4 and 5, which adds up to 9. Huh. So then this becomes 3, 5, 6, 7, 8, 3, 5, 6, 7, 9. This obviously can't be 5. This can't be 9 or 3. So in column 5, we have a 5, 6, 7 triplet, which means the 5, 6, and 7, excuse me, cannot be in the rest of the cells. So therefore, this is a 3, 9, 3, 9 pair. Okay. What does that mean? I'm not really sure. This can be 2. Actually, we have a 5, 7, 8 triplet in row 5. So that means 5, 7, and 8 cannot be in the rest of the row. So therefore, this is also only 2 and 4. So this is 2 or 4, this is 2 or 4. This can't be 2, therefore this must be 4, which makes that a 2. Since this is 2, it can only go with 7, 6 or 7 to become 8 or 9. So that's fine. This is 2, this is 4. Where is a 2 in column 2? It cannot be in the red because we have a 2 there. It can't be any of these cells because of the Renban or the other 2s, or they're already a different digit. Therefore, this must be a 2. And it cannot be light then. It has to be the medium gray. Therefore, to connect to the 9, this one must be light. So those are done. Therefore, we don't actually have anything else there. All the 2s, I think, are done now. Yeah. All the 1s, there's still a lot of 1s left. The pink needs a 1 and it needs a 3. And this can't be 1. Oh, where's the 1 in column 4? Cannot be the red, cannot be any of these because of the 1's already there. So it must be one of these 2. The ones in column 6 have to be one of those 3, and it has to be one of those. So, okay, what's the last remaining digits in column 7? It has to be 1, 3, and 8. So this is 1, 3, 8. This is 1, 3, 8. Can't be 3, though. This can't be 1 or 8, so therefore this has to be 3, which forces this to be a 1, 8, 1, 8 pair here. So this is 3, which means neither of these 2 can be 3. So these can't be 3 then anymore. The 3 can only be in one of the space now, in red, so therefore this has to be 3. Therefore, where is the 3 in column 3? It can only be here now. So this is 3. Where is the 4 in column 3? It can only be here. So this has to be 4. Where is the 5 in column 3? It can only be here. So this is 5. So this is 6, 7, 6, 7, 8, 6, 6, 7, and 8. So these can't be 5. Therefore, this cannot be... This is 8 and 9. So this is an 8, 9 pair. So the rest of the column cannot contain an 8 or a 9. So this can't be 8. This sees these 2 cells by being in the same region and this cell by Sudoku. And we know 6, 7, or 8 are uniquely in those 3 cells. So this cannot be 6, 7, or 8. Therefore, this must be a 5. Since this is a 5, that makes that a 7, which makes that a 6. That means this can no longer be 9, so this is 8, which makes that a 9, which makes that 8. This makes that a 6. This 7 makes that an 8. Therefore, you cannot have... this can't be 6 or 8. There's no more 6 or 8s there. And this can't be 6, and this can't be 9. Because of that 9. Yeah. So this is 5, which means this can't be 5. We have a 6, 7, 6, 7 pair in column 1, which eliminates all 6 and 7s in the rest of the cells. So therefore, this must be 5. So this is 2 plus 5, which makes that a 7, and therefore that's the only place to put an 8. This can't be 7 anymore, therefore this is 4, this is 7. This has to be a 6 and a 9. But 9 can't be anywhere here. Therefore, this must be the 9, and this must be 6. So this can't be 8, and this can't be 8. Where is the 8 on this Ren band? It has to be here. So this is 8, this is 6, 7, 6, 7. This can't be 8 or 6, this can't be 6 or 8, this can't be 6 or 8. So this is 5 or 7. We know one of these two cells is 7 for the orange region. Therefore, this can't be 7. Also, well, okay, yeah, we don't know. So this is 5 or 9. This can't be 6 or 8. This can't be 4, so this is 5 or 7. Interesting. We have a 5, 6, 7 triplet now in row 2. So the rest of the row cannot be 5, 6, or 7. It can't be 2, 3, or 9 already because of the digits there. Therefore, this has to be 1, 4, or 8 here. And this is 1. Can't be 1. Could be 4 and 8, though. For the blue region, this has to be, what, 7? So this is 7. And we have, what, 5 and 6 here. So this is 5 and 6. This is 5 or 6. Oops. So, again, this is 5 or 6, and this is 5 or 6. This can't be 7 anymore, so where is the 7 in row 4? It has to be here. And the orange needs a 7, so this has to be orange. So this cannot be dark. This can't be orange anymore. Therefore, we have the boundaries for orange now. The orange region. This can be only 4, 5, 6, and 8. It can't be 4 or 5. It can't be 8. Therefore, this has to be 6 now. So this can't be 6. This is 5, which makes that 6. This can't be 6, so this must be 7, which makes that a 6. This can't be 7, so that's a 6. So this can't be 6. This is 5 or 7. This can't be 7, though. So therefore, this is 5, which makes this a 7. Okay. This has to be 1, 3, or 9. It cannot be 3. This is 1, 3, or 9, but it can't be 3. Therefore, this is 1 or 9. And we have a 1, 9, 1, 9 pair in row 3. So the rest of the row cannot contain a 9. Therefore, this is 3. This is 9. Oh, actually, we could have done it that way, too. That would have probably been easier. Where does the pink have access to a 3? It cannot get to here. It cannot get to here. And those are the only 3s left. Oh, this is a 3. So this cannot be medium because we already know that's a medium. So this has to be dark. This can't be medium or dark. Therefore, this is the pink. So we have 6 pinks now. Let's see. This is 1, 5, or 9, but it cannot be 9. So this is 1 or 5. So we can delete essentially these. What about this? This can't be 8, so this is 1 and 4. And remove the outer ones. This has to be 1, 4, 5, or 9. It cannot be 9, so this is 1, 4, 5. This is 4, 8 also. Okay, so I think... Oh, this has to be 7. This is not pink. So it sees 2 and only 2 cells. So if this is dark, it sees this one, obviously. That doesn't help. Orange is done. Yellow's done. This can't be 6, so this must be 7, which forces this to be 6. That's fine. Green is done. Pink is kind of done. It still needs... Okay, 5. Pink needs a 5. It could go actually all the way up here. That's fine. If that's the case, then it would be 9, 1. So it cannot go up to there. So if it avoided this one and went up to here, it would have to be these 3 specifically. And the only remaining numbers, digits in pink are 1, 5, and 9. So this would have to be 5, 1, and 9. But then the problem is this can only be 5 and 9. And so therefore, having pink beat go all the way here would eliminate that. Oh, the 5 could be one of these two. Well, okay. Again, we were trying to make pink this one. Therefore, this cannot be the pink, because it would have to contain these 3 digits, would be 1, 5, and 9, and that would eliminate all possibilities for this cell. So this cannot be pink. It's either medium or dark. Can this be medium? If this is medium, this would be 9. So if this were medium, okay. Well, it could go this way. Okay, if this is medium, that means all of these are medium. It cannot go this way because of the 9, because it would have 1, 5, and 9 as the 3 cells. But it can't go this way either, because it would have a 5. So therefore, it would be blocked here. So this would be 1, 2, 3, 4, 5, 6, 7. And that's not possible. So this cannot be medium. This has to be pink. Also, actually, the medium needs an 8 somewhere. It could reach all the way here, though. Yeah, this could be all medium. If this is dark, though, what does this have to be? This would have to be dark here to basically add up, but you need another one, and so it would have to be here. So this can never be dark, because if this were dark, it would contain both of these to add up to a number, and it wouldn't even add up to 7, so this can never be dark. So this is medium. Therefore, we have a 6 here, and we need a 1 to add up to 7 for this medium. So therefore, this can never be 1. So therefore, this is 5, which forces this to be 9, which makes that a 1. This cannot be the 1 in medium gray, because we need that 1 to add up and form a knight's move to add up to 7 with the 6. So this cannot be medium. This is pink. So we know this is pink. So we have 1, 2, 3, 4. This is 5 also. And this can no longer be medium, because we already have a 5 in the medium. This can't be medium. This has to be pink or dark. So this is pink or dark. This is pink or dark. We have 1, 2, 3, 4, 5, 6, 7, 8 already. One of these is the pink. Therefore, this can't be pink. Therefore, actually, where is the medium gray go? It has to go here. And then it has to go here, because it can't have the 5. This can't be 5 anymore. This is 1 or 4. This must add up. Okay, so say we tried to make... Okay, this has to be 9. So this cannot be the medium. This has to be dark. Also, this is a knight's move away from the circle, so this has to be 1. So this is 1, which makes that 8, which makes that 4. This is now 1. This is 8. Okay, so then now we need to figure out the coloring before we actually solve this. So this is 4. This is 4. This 1 cannot be medium, because we already have the medium 1. The 7 cannot be medium, because that's already medium. Therefore, this is dark. Since this is dark and surrounded by darks, this must be the dark. So this is dark. This is also surrounded by darks, so therefore this must be dark. The dark already has 2 that it sees, so it cannot see another 1 in its region, so therefore that's pink, and this cannot be pink, so this is dark. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, wait, this can't be dark, this has to be medium because of the 8s. And therefore we have 1, 2, 3, 4, 5, 6, 7, 8, 9 for dark, so this cannot be dark. And now we have all the regions. So this is the region, this is a region, and this is a region. And now we finish it, and that's a 4. Pretty straightforward, actually, considering. Well, okay, there was one part that was a little tricky. But I always felt like I always knew sort of where the next step was going, right? And I like that from from these puzzles, right? I don't feel like completely lost and then just randomly guessing. Or not randomly guessing, randomly checking random stuff. This always sort of felt like it was just it flowed from one to the next, right? I particularly like the circles. The circle being this circle thing where you basically had to be in different regions was very clever. I like that idea. And it just sort of flowed naturally from just the rule set, which is great. And so this was a very fun puzzle. And I hope you enjoyed this puzzle too, in this solve. And I'll see you next time on Frank Puzzles. Take care.